we are presenting our machine learning assignment on wine quality prediction using supervised learning techniques. The objective of the project is to predict whether a wine is good quality or bad quality based on its chemical properties. We used the wine quality dataset obtained from the UCI machine learning repository, which contains both red and white wine samples. In this project, we applied 4 supervised machine learning algorithms: logistic regression, decision tree, random forest, and support vector machine. The dataset consists of 6,497 wine samples combining both red and white wines. Each sample contains 11 input features such as acidity, sugar level, pH, and alcohol content. The large target variable is wine quality, which originally ranges from 0 to 10. For this project, we converted the problem into binary classification. Wine with quality 6 or above are considered good, and wine below 6 are considered bad. We then performed pre-processing steps including merging red and white datasets, handling data format consistency, feature scaling using standard scaler. The dataset was then split into training and testing sets using an 80:20 ratio. We will now explain each part of our work and the result obtained.
Hi everyone. In this part of our machine learning project, I will explain the logistic regression model that we use for wine quality dataset. So the main goal of this task is to predict whether a wine is high quality or low quality based on its chemical properties. The original dataset contains 2 files, red wine and white wine. And in the first step, I'm gonna load both datasets using pandas and then combined into them a single data frame using pd.concat function. After the conversion, after the loading the data, the next important step was converting the target variable into binary classification problem. The original quality columns contain numerical scores, but since logistic regression is mainly used for classification, I transform the values into 2 categories. If this wine quality is above 6 or above, it is labeled as 1, which means it's high quality wine, and nonetheless it's labeled as 0, which means low quality. This conversion allows the model to classify wines into 2 clear categories. So the next part is I separate the dataset into features and target values. The feature matrix X include all chemical measurements such as acidity, alcohol level, sugar, pH, while the target Y contains the binary quality labels. Before training the model, I applied feature scaling using standard scaler. This step is very important for logistic regression because the algorithm performs better when all input features are on a similar scale. For example, alcohol percentage and residual sugar can have different ranges, so scaling helps normalize them. After pre-processing, I split the data into training and test sets using training test split function. I use 80% of the data for training and 20% for testing, which helps us evaluate how well the model performs on unseen data. Then I created the logistic regression model using skitlearn. I said max iter for 1000 to make sure model has enough iteration to converge properly. After that, I trained the model using the training dataset with the fit function. And once training was completed, I used the model to make predictions on the testing dataset. To evaluate the model, first I calculate the accuracy score, which shows the percentage of correct predictions made by the model. In addition to accuracy, I also generated confusion matrix. This helps us clearly see correctly predict that high quality wines, correctly predict low quality wines, false positive and false negatives, such as. I visualized this confusion matrix using heat map, which makes it easier to interpret during analysis and presentation. This is the confusion matrix using heat map. And next I use the predicted probabilities to plot the ROC curve. The ROC curve shows how well the model distinguishes between the two classes across different thresholds. I'll also calculate the AUC score, which summarizes the ROC performance into a single value. A higher AUC value means better classification performance. To further validate the model, I applied five-fold cross-validation using cross-val score. This gives multiple accuracy scores across different splits of the data and helps confirm that the model is stable and not dependent on just one train test split. Finally, I saved the model's final accuracy result in a CSV file. And in conclusion, the logistic regression provided a simple, fast, and highly interpretable baseline model for wine quality classification tasks. Although there are more advanced algorithms may achieve slightly high accuracy logistic regression, but logistic regression gives us a very strong foundation for our comparison. And thank you.
My name is HGB Hevaduwa and my contribution to the project was implementing the decision tree classifier for wine prediction. Before I show the results, let me quickly explain what a decision tree actually is. A decision tree is a machine learning algorithm that makes prediction by asking a series of yes or no questions about the data. Imagine a flowchart. At each step it checks one feature like is the alcohol content about 10.5 and branches left or right based on the answer. It keeps asking questions until it reaches a final decision. The reason we chose it for the project is that it is easy to interpret. You can literally read the rules and it learned, and handles both numerical and categorical data very well, which suits our mindset dataset perfectly. So to begin with, let me walk through the key steps in my notebook. So first I split the data into a training dataset and a test data, 80% for training, 20% for testing. I use stratified splitting, which makes sure both sets have the same ratio of good and bad wines. Next, and the most important step, I turn the max depth parameter. A decision tree that's too deep will simply memorize the training dataset and fails on new wines. So I ran a loop test in depth from 1 to 20. Plotting a training accuracy against test accuracy. The point where test accuracy peaks without the gap, the training and test becoming too large. That's the best depth. I used that value for my final model. Finally, I trained my model using class weight balance because the dataset has more bad wines than good wines. Without the correction, the tree would be biased towards always predicting bad. So here are my results. Looking at my classification report, the model achieves a reasonable F1 score, which means the model is both accurate and consistent. The confusion matrix shows where the model makes mistakes. The diagonal cells are predictions. The off-diagonal cells are errors, wine that were mislabeled. You can see the model find it harder to correctly identify good wines, which is expected given there are fewer of them in the dataset. The feature importance chart shows the chemical properties and relied on most. Alcohol content came out as the strongest predictor, followed by the volatile acidity and sulfates. This makes intuitive sense. High alcohol wines tend to score better, and high volatile acidity makes wine taste vinegary. Finally, my ROC AUC score measures how well the model separates two class overalls. A score of 0.5 means random guessings, and 1.0 would be perfect. My score is above 0.7 and shows the model is genuinely learning something meaningful from the data. So the decision tree is highly interpretable. I can literally show you the exact rules it uses to classify a wine. The valuable wine setting where you need to explain its decision to non-technical people. Overall, the decision tree gave us a solid interpretable baseline. It's not the most powerful algorithm ever, but it gave us a clear insight into which chemical properties drives wine quality. And that has understanding is what we build as a team. Thank you.
The third model used in this project is random forest, which is an ensemble learning method based on multiple decision trees. It works by building several decision trees using different random samples of the training data and also selecting random subsets of features at each split. This randomness helps reduce overfitting and improves generalization. For classification, each tree gives a prediction and the final output is decided by majority voting across all trees. In this project, Random Forest achieved the highest accuracy of approximately 82% compared to the other models. We also analyzed feature importance, which helps identify which features influence the prediction most. From the result, alcohol content and sulfates were found to be the most important features for determining wine quality. Overall, Random Forest performed best because it handles nonlinear relationships well, reduces variance, and provides stable and accurate predictions.
The fourth model used in this project is support vector machine, which is a supervised learning algorithm used for classification problems. SVM works by finding an optimal hyperlane that separates different classes with the maximum margin. The main idea is to create a clear boundary between good and bad wine samples while maximizing the distance between the closest data and data points of each class. Since the dataset contains nonlinear relationships, we use the radial basis function kernel to map the data into a higher dimensional space, where it's become easier to separate the classes. Before training, feature scaling was applied using standard scaler to ensure all features contribute equally to the model. We also turn important hyperparameters such as a C and gamma to improve performance. After tuning, the SVM model achieved an accuracy of around 78%. SVM performed well on this dataset because it can handle complex patterns efficiently, but it required proper parameter tuning and it is sensitive to feature scale. When comparing all models, Random Forest performed the best with the highest accuracy. SVM also shown strong performance. Logistic Regression had the lowest accuracy. Decision tree performed moderately. So, therefore, Random Forest was selected as the best model for this problem. Now we will demonstrate the prediction system. We enter the chemical properties of the wine sample and the model predict whether it is a good wine or bad wine. This shows how the model can be used in the real world applications. In conclusion, we successfully applied multiple supervised learning algorithms to predict wine quality. Random Forest achieved the best performance due to its assembled nature. Feature improvement could include hyperparameter tuning, feature selection, and deploying the model as a web application. Thank you.